How's it going, everybody? In this video, I am going to demonstrate a couple of relatively basic layer 2 VPN capabilities, and this is part of my ramp up to the SP written for SP written and SP lab for CCIE. So I've spent a pretty significant amount of time covering these topics already, studying them and whatnot. So my goal now is to go through and show you some basic demos. I really haven't done a whole lot layer 2 VPN yet. I've done a fair amount of layer 3 VPN, but I want to start getting more into the habit of releasing videos on a pretty regular basis as I go through the rest of the track. And the reason for that is because I have begun the CCNP service provider videos because the workbooks are now complete. So I'm making my way through core, and I'm finding that the videos are coming out really quick. I don't have to spend 20 minutes trying to figure out how to configure something because I already know how to do it. So they'll be coming out as quickly as I can get them recorded. I'm really not looking for quantity, I'm looking for quality. So just keep your eyes peeled for that. They are, because of the fact that I've got a CCNP server in service provider, I'm not waiting to release them. I am simply they are immediately available when they are done being recorded. So there's already a few videos up. I just have to upload the other stuff that I've got. So NP service provider material is available currently. There's only a handful of videos though because I just started recording. But enough about that. We're going to take a look at some basic layer 2 VPN. And so as you can see on these routers, I got a couple of main interfaces configured, and I've got them mapped through ESXi. So the goal here is to demonstrate leveraging Ethernet flow points, and underneath R1 and R3 to do a point-to-point pseudo-wire between R11 and R14. And then we're going to do a basic static VPLS with R13, R12, and R24, getting them all together. So the main goal right now, first and foremost, is to verify that we have reachability between R1 and R3, and I do. And as long as I have that, I know I'm in pretty good shape. So the first thing we're going to do is, underneath interface gig 2, we're going to type in service instance 1 Ethernet, encapsulation.1q, and we're going to say, for the simple fact, we're going to type in 100. Normally I wouldn't do mismatched numbers. I would do service instance 100, encapsulation.1q 100, but this works for the basic configuration. So what I'm going to do now is I'm going to say interface pseudo wire 100 or 13. Encapsulation is MPLS. My neighbor is 192.0.2.3 with pseudo wire ID 13. And that's really all I have to do. Now I just have to go to L2 VPN XConnect context and type in point to point L2 VPN. And underneath here just type in member is going to be gig 2 service instance 1 and member pseudo wire 13. And that's really all we have to do. Make sure to exit out of the XConnect configuration or else it won't work. Same thing on R13. We're going to go to under interface gig 2, service instance 1, service instance 1 Ethernet, encapsulation.1q is 100. Interface pseudo wire is 13, encapsulation MPLS, neighbor is 192.0.2.13, 13, and L2 VPN XConnect context is going to be point to point L2 VPN, member gig 2, service instance 1, and member pseudo wire 13. Get out of that, and that should bring all of our configuration up. We're going to do a show XConnect all, and it's currently down. Wonder why that is. Show run interface gig 2. So let's go check. R11's good there. One of the things that I'm going to do here is interface gig 2.100, encapsulation.1q 100, IP address of 10.1.100.11/24, and router EIGRP 1 network of 10.1.100.0, and do show history. And we're going to take that same logic here. I'm going to grab Notepad real quick, make a quick modification change, make that .12, or make that should be 14, I believe. Let me just double check that real quick. So on ESXi, if we bring this guy over, this is one of the reasons why I keep it up and available. Let's see what we have here. I didn't double check this before I started. So on R3 side, R313, R314. So yeah, R3, this should be, it's 13, not 14, because I'm going to interface 2. So that should be all I have to do there. Go over to 13 and copy, paste like that. And as soon as I get this figured out as to why it's not working, we'll see show xconnect all. So it's down. Show run interface gig 2. Show pseudo wire. Show interface pseudo wire 13. Okay, so it's there. But why is it not coming up? Oh, you know what? I bet you any money. Show run section license. License is there. What about 13? Or show run section license. License. Okay, so it's not a licensing problem. Let's see. Show L2 VPN, AToM, VC. It's down. Why is it down? Doesn't make any sense. Show L2 VPN, AToM, VC. Well, they've got the same. Oh, that's why. There's our problem. Interface pseudo wire do show run interface pseudo wire 13. That's why. Interface pseudo wire 13. Neighbor is 192.0.2.1 13, and there we go. There we have it. And router 11 just forms an EIGRP adjacency. So that's what you would expect to see. So that's better. Okay, so fat finger on my part broke it. Well, fat finger. We'll just call it what it is. So we end up getting this EIGRP adjacency now, and that's what you should see. CSRs do support it in the data plane, fortunately. So that's basically a point-to-point pseudo-wire. Pretty simple. Now on 12 and 14, they're connected to gig 3 and gig 3. So just to double check on that, we'll pull up ESXi again, and we'll check on R1. We'll come down here to edit settings, and gig 3 is R12, which is exactly where I want it to be. And then on R3, R14 should be attached to gig 3, which it is. So now I know when I go to configure this, I'm going to go to R1. I'm going to go to global config, interface gig 3. I'm going to type in service instance, we'll say 101 Ethernet, encapsulation.1q 101. We're going to exit out. And now one of the things that I have to do is I have to create a pseudo wire between R1 and R3, R1 and R2, R2 and R3. So this is actually going to be very easy, but the magic here is that the pseudo wire virtual circuit ID needs to match between the PEs. And this is a manual configuration. We're not doing any BGP auto discovery or anything like that. You can, and that does work. We'll test that out. I'll do probably a BGP AD video, or BGP AD with LVP signaling. So interface pseudo wire, and we'll say we'll type in 101.13 because we're going to be doing encapsulation.1Q101. I'm going to type in encapsulation is MPLS, neighbor is 192.0.2.3 101.13, and then as long as neighbor of 192.0.2.3 and the 101.13. So as long as we do that on both ends, we'll be okay. So we're going to exit out, and then I'm going to do another one here. I'll say the interface pseudo wire to 12. The encapsulation is going to be MPLS, and the neighbor is going to be .2, but going to 12. And that's really all there really is to it. Now what I have to do is type in L2 VPN VFI X context is going to be multi-point to multi-point VPLS, and I'll type in member, or a VPN ID is going to be 101. Member is going to be pseudo wire 101.13 and pseudo wire 101.12. So I exit out, and then I create bridge dash domain of, we'll call this 101, and we'll type in gig member is going to be gig 3 service instance 101, member VFI 101, or what is the name of that thing again? Right there. There's the VFI context. We do that. So now what I'm going to go do, and so it brought it up, we're going to exit out, and I'm going to type in, you can, once you've got one of the nodes in the configuration up and running, it makes it a little easier to go through and configure the other ones, because then you just got to tweak little things. So I'll type in, do show history won't take me back far enough. You know, history, I don't know if you can modify logging history, and size we'll say is 100. I'm just do show history. Yeah, it's, I guess we have to, is that going to be the, maybe not, or maybe it starts going back from the beginning. So do show run interface pseudo wire 101.13 12, and we'll type in show run section L2 VPN and bridge. So do show history. Yeah, it doesn't change the history. So what we'll do, just to speed this process up a little bit, is I'll take the same configuration I did here, I'll whack that out, and we'll take the pseudo wire config from here. Well, this will go to router 3, and we'll do this, but instead of being pseudo wire 101.12, will be pseudo wire 101.23. And then the VFI and the X, yeah, this one right here will get changed, and this one right here will get modified. And that's really all there really is to it. You'll also have to change the interface config, so do show run interface gig 3. Oh, gig 3. We'll grab the service instance right here. Alright, so what we need to do, configuration wise, and the way that I've got it broken down actually should be more like this, so that it's easier to follow. So you first configure the attachment circuit interface. So in this case here, gig 3. This is the service instance, and then we're going to create. We have the pseudo wire from R3 to R1, so I'll just change this one back towards router 1, and this one will be 23, but it'll point to router 2, which it is. And then I'll just have to come in here and I'll change this one to be 23. We got 13 there, and then they call it. And then that makes it pretty easy to follow along, and everything else is pretty straightforward. R1 and R3's config are pretty close. We'll go to R3, and then we'll configure that. Oh, you know what, did I not? Oh, whoops, my bad. That's what happens when you copy stuff, do a show run. My fault. Oh, and now it's gonna freak out. So I'll pause the video for a couple seconds and wait for that to finish up, and then I'll copy the config in. I threw the end in there, and I'll have to go in and disable no IP domain lookup, which is why this is trying to DNS resolve what's going on. Alright, so now that we've gotten past that point, which didn't take very long, go ahead and drop the config in like that. We'll exit out, and that should be pretty much all I need to do. And what we're going to do then is on our R2 side, instead of being gig 3, we'll put this to be gig 2, and we'll say 101, we'll say 12, and this will be 12, and this will go back to this guy. We'll put this guy in here as 3, and this will be 12, and that should be pretty much all we need to do. Gig 2 service instance 101. Let's see. Just make sure I'm verifying everything as we go here. Gig 2, 12, pointing to R1, 3, pointing to 3, and 23. Yep, that all looks good. Let's go to R2 and get him squared away. So we're going to go ahead and copy and paste this in, and you'll see the LDP neighbor comes up to R3, and we'll have to see show X connect all. So our connection to R2 is up, which is good. What we'll do now with the next step to the process is go to R12, for instance here, and we're going to have to go interface gig 2.101. Type in IP address is encapsulation.1q 101. IP address here is going to be 100.64. I'll do 10.1.101.12/24, and I'll do router EIGRP 1 network of 10.1.101.0.0.0.255. Do show history. I'll grab this config right here, and I will copy it to here, and I'll change this config here to be 24 on router 24. So router 24, we'll drop this config in here, and do show IP interface brief. We're going to go ahead and copy and paste that in. I have an adjacency to router 12, and then we'll do the same thing, but we'll do this on router 14, because that's where the other end is. Grab that, go to router 14, copy and paste that in, and then we form adjacencies with 12 and 24. So what that means is if we go to router 1, we do a show bridge dash domain, we're going to see a couple of things. First and foremost, we're going to see the EFP, this interface right here. Anytime you see gig 3 or a numbered interface that defines a physical interface on the local device, that's your Ethernet flow point. So I'm not going to go into any real details of what EFPs are, but this one's here is showing us that we received this MAC address in from the customer. So this is from R12. Now we see that we've learned 2 other MACs from the MPLS or the multi-point to multi-point VPLS. These are the pseudo wires, one going to R12, one going R2, and one going to R13 or R3. So typically, whatever the last number is, sometimes it matches, sometimes it doesn't. It's been kind of inconsistent. But the MAC addresses come in, I see what they are. So what ends up happening from a high level is you create the attachment circuit. So if we go back to, can I go back? Oh, it's not going to let me go back. So first and foremost, just to help you understand the logic here, show run interface gig 3, you first create the attachment circuit. This connects to the customer. Once you've created the attachment circuit, and obviously if you don't do any configuration inside of ESXi at the host level, create the V switches, allow promiscuous mode, and allow the port group to be basically a trunk connection between R1 and R11. And I did another video previous to this that I demonstrated how to do all that. As long as you've done all that pre-work, then the connection between R1 and R12 will be there and ready to go. So I'll go in later on, I'll add descriptions to the interfaces so that it's easier from a verification perspective to what's going on. So this is the attachment circuit. It goes down to the customer. The next one is going to be show run interface pseudo wire 10112. This connects to R2. This one connects to R3. These are going to be your, this is how the control plane is built. So there's going to be a VPN label that's associated to this. So when I go to forward the traffic over the network, I'm using the pseudo wire to build the connectivity between here and there. So when I go to, if I do a show L2 VPN or VFI, and I hit the enter key, you're going to see that I have these two pseudo wires, and the VCID is there. If I do a show XConnect interface pseudo wire interface, no, sorry, it's not XConnect. Show L2 VPN AToM VC 10112 VCID 10112 detail right in here. Where is it? The local, we have a local label and we have a remote label. So the local label is 32, the remote label is 30. So when I do a show MPLS forwarding and I look at how do I get to R3 from here, I'm going to use 24,005 because that connects me to XR1. So I end up having a situation where, and I think I have a VM running, the traffic is encapsulated. I use 24,005 to get me from R1 to R3, but I use label 32, or I'm sorry, I use label 30 to get is like the VPN label. So that's how it gets encapsulated over the core to the remote end. So VPN label, transport label, and you can see down here I got two down. So if I go here and I do show MPLS forwarding table for labels, let's say 30, let's say no, 31. It's a point to point. They're both point to point. But if I say detail, it's going to tell me that it says the label stack is empty, which isn't true, but it's pointing to a different connection. So let's see, do I have that VM running? I believe I do. I do, right here. Let's open console. Alright, so we'll come back in here and I believe Wireshark is working. So we're going to, continue without saving. So we're going to come in here and type in ICMP, or you know, anything else really. We'll go to R11. Actually, I could probably just do EIGRP too. So right here we have this going across, and you'll see 32 is from 12 here, and 12 and 13 we see it going back and forth. We see label 32. This is coming from but if I go to 12 here, or I'll put in or ICMP, and I'll put in on 12, I'll ping 101 ping 10.1.101.14, and I'll ping, and if we stop the capture and I bring it back up here a little bit, you'll see that I send a ping from me outbound. But what you need to understand is we have label 30, label 24,005. So this label right here is the VPN label. This one here is the transport label. So I'm going across, and then you see label 30 get popped, or I'm sorry, 24,005 get popped, and you get the reply is in the reverse order. So 31 on R3 side. Now I'm going to go into a lot more detail on how this all works in CCIE. Well, and that's one of the reasons why I have it set up the way that I do. So I'll be able to walk you through the recursion process and stuff like that. But I wanted to show you a relatively quick video that will show you both connections and stuff like that. And if you look right here, we'll see that for R11 to go to so let's see, we're going to see 12, so we'll see label 30 and label 31. So on R1, if we go over here, we see labels 30 and 31. Those are the VPN labels. So this one right here is coming from R11. This is the local label to get us to, and this is the VPN label. The transport label is the other one. Anytime you see this right here, where you see the bottom of stack bit enabled, bottom, the S here is 0. When you have that, that means that that's a VPN label, because that's going to get popped when it reaches the remote end. So this is when that VPN label is received on R3 side. Show MPLS forwarding table. When you see this guy right here, when you see label 30 received right here, so we'll take labels 30, and we do detail. It doesn't point to an outgoing interface, because this is a bridge domain connection, so I'd have to recurse. But if I did label 31, though, it's going to point out gig 2, which is the point-to-point pseudo-wire. So this is going to be whatever label is associated to your pseudo-wire through the XConnect configuration. That label is the VPN label. That's the actual customer route, or customer traffic, if you will. The transport label will always be the label that the core is going to use to get to the remote end of that pseudo wire. So if R1 wants to get to R3, R1 has to come in here and do a lookup and say, how do I get to 192.0.2.3? I'm going to use label 24,005. That's how that comes into play. So as long as you understand the recursion process, you'll be in pretty good shape overall in order to get this done. And like I said, if you hang out and you wait for the CCIE content that I've got, I'll be starting to record that here soon. I have some stuff that I have to cover yet, and that will be out soon. Well, you won't actually be able to watch it until after I pass the lab. So if you're waiting for it, it is going to be coming. It's just going to take some time for me to obviously pass the CCIE for service provider and get done with that. But this topology that I've got built currently is what I'm going to be using for testing all of that out. So this should allow me to test almost every capability. This will actually get tweaked. This is the inter-autonomous system variant. I have one for a single AS. There's going to be a lot of content just on a single AS, because we have to cover just a ton of material. So like I said, the material is on its way. It's going to take a little while for it to get recorded and then eventually released. I want to thank everybody for stopping by. If you're still watching, thank you so much for helping me out and supporting the channel. Until next time, guys, take it easy.